Alrighty then. Yeah, I think that clap actually made it. All right. Number one, I should not be here right now. Why do I say this? Because this past Wednesday, on my monastery life number 8, I said that I was going on the ride back home to the East Coast to run into some folks along the way. Well, you ever you ever have a plan? And I know a plan. Who's this guy to have a plan? You ever have a plan? You plan things out and you allocate the time, you look and you're like, all right, it's gonna go exactly this way. I'm gonna be able to do all these things, and then it never goes as planned. Yeah, I had one of those days. So let's all right, where are we? What type of day was that? Well, if you couldn't tell from the thumbnail, yes, the screaming for attention thumbnail. All right, let's bring that up and we'll share it over here. All right, this is where we are at, folks. MML number 9. When things go wrong. What went wrong? Okay, so thing is, I was supposed to be going cross country, and under warranty, this is the first time an extended warranty has overpaid for itself. Basically, after I drove back across country, I was lucky. All of a sudden, the engine light comes on. It's like, oh, your engine is overheating. I'm like, well, that's not a good thing. So turn the car off, wait a few minutes. And I'm like half a mile from like where I bought the car. So I drive back to the dealership. The bada boom, bada bing. They throw some stuff in, a little water. It's basically the radiator like drained out. Long story short, they're like, you need a new engine. Well, they said it would take about a week after they got the engine. A couple weeks later, they got the engine in. All right, and about a little over a month or so later, they got me a loaner car and everything. They got me the car back. It worked phenomenal. I had new brakes and everything. It was amazing. I drive off cross country. I should have gotten an oil change. And I take a trek up to the great Northwest. Oh, hey Rick. Um, so basically it got very steamy at one point, Rick. Oh, hey Lug. Hope you're doing well, my friend. Um, don't worry about anything. I'm totally fine. Totally fine. There wasn't an accident. Well, okay, there was an accident, not the standard automotive one. Okay, we'll get into that. So I get the car back. I go up. I visit Rick, my stepbrother. I go out to Portland and everything. See Anastasia and Shiloh from the Demystify Side podcast. They put us up for a night and fed us, and we come all the way back across the desert. And eventually I'm like, all right, I need to go back to the East Coast. I'm going to go get an oil change because I haven't changed my own oil in years because I'm a terrible dude. But so ultimately, what happened, I'm in there and I'm like, they have the standard advertising. So they're like, oh, you should change your battery like every 4 years or so. I'm like, when was the last time I changed my battery? And I think back, I'm like, oh, the last time it died, which it was pretty cold out then. So I'm like, it seems to be of the magnitude 4 years. So I'm like, all right, can I get a battery too? All right, they put the battery in and everything. I'm all set. I'm ready to go. Of course, I leave late at some point, still in the morning time, luckily enough, yesterday. I'm driving. I'm like, I was going to go up through like Rochester, Minnesota, visit a friend and stuff as I was making my way towards Ohio and everything. And ultimately, rather than just doing the standard thing where it's like, all right, just play with my GPS more, I'm like, oh, it's sending me up through the canyon. I'm like, well, that saves 26 minutes. There's a 120-mile stretch where there's like nothing there, but I have fresh oil and a new battery. What could go wrong? Oh, my friends, things went wrong. Things went wrong. Luckily enough, I broke down in the worst, best place. I say that because had I gone on for another like hour or two before this happened, there's about a 120-mile stretch from Utah going into Wyoming for a bit. There's not much out there. Maybe some wolves. There's not much, and occasionally you might not have service. Okay. That would not be a good place to break down. Fortunately, I broke down on a weekday afternoon, literally at noon, after going through the raggedy edges of the ravine and everything, where there's literally like, okay, there's two way. Okay, you can have two lanes, one going one way, one going the other, and there's a creek on one side and there's like sheer rock on the other. The engine did not seize right there. I'm going along, I'm getting close to the peak. It flattens out, and then all of a sudden I'm like, I don't seem to be accelerating. What what could be going wrong? I'm like, all right, so I'm like, yeah, that car doesn't seem to be accelerating. I'm like, I push down the gas. I'm like, oh no, my transmission. And I'm like, I asked them if I need a transmission plus like early in the year or something. They're like, no, 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 you're not 100,000 miles yet. So I'm like, oh no. And then like it revved up a bit. And I'm like, all right, this isn't good. I'm like, maybe the new battery, maybe something's wrong with the sub. Pull over quick. All right, turn the car off. I'm like, all right, see if I turn it back on. It tries to turn over a little bit. I'm like, all right, I'm like, hmm, I wonder. I get out. I look underneath the car. I'm like, oh, there seems to be something dripping. Let me touch it. Because, well, duh, that's what you do in all the crime things. You touch it. I didn't lick it because oil. I looked at it. I'm like, all right, this looks kind of greasy. This looks like fresh oil that was in my engine that's now dripping down onto the ground. And I'm like, all right, in times like this, my mom got me a fancy AAA membership for Christmas last year. So I'm like, all right, I can call AAA. I happen to be in the part of the canyon where you're surrounded by mountains. There ain't no reception. Did not have a satellite phone on me. Had I, maybe it would be different. Um, Fortunately, breaking down literally like right at about noontime on a Thursday on it's it is kind of an interstate, but it's oh my god, breaking down on 95 or 93 on the East Coast, you're like, oh please, please, I don't want to die. I don't want to die. It's gonna feel so. Within 10 minutes of breaking down, two good Samaritans showed up. It's like one dude in his truck is like, I'll give you a ride up to the ski area and stuff. And I'm like, no, 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 I'll hitchhike or back that way. I'm like, I got some friends in town and stuff. I literally only about a half hour or so away. So fortunately, it wasn't the furthest drive. So ultimately, the next gentleman, he was actually he was in his like carpet cleaning vehicle and stuff. He was a little oh god, was his name was Rick actually, I believe. Yes, I remember that for reasons. But Rick had given me a ride up there, and he owned apparently one little like skate rink and stuff like that up there around like Idaho and everything. Very nice show. Me, he took me up to the summit because once you get to the summit, and you're overlooking kind of um, it's Bear Lake. It's a very gorgeous. Hold on, let me bring up some pictures because it is actually a very gorgeous site. Let me see. Bear Lake. I think, this Bear Lake, Idaho, Utah. Here we go. All right, present. So you're right over here. So yes, yes, they're cycling through the photos. This is it. It actually looks really. Let's see if we can scroll through it a little bit and see if they got any snow in the mountains. They're just showing the summer photos because that's usually when it's very busy. All right, so let's go to here's Bear Lake. 89 is where I broke down. I broke down. Where is it? Yeah, probably right along here. Right along here. Yep, yep. You see that? Yeah, yeah. Those are visualizations are mountains and stuff like that. I broke down on the flat place over there, and then I got a ride up to yeah, right before the nature trail. There's like an overlook over here. It's actually very pretty. Uh, is it on here? It might have it if I zoom in a little. Yeah, here we go. Yeah. So this is where I was. Yeah, it looks. Yeah, it looks kind of like that. But it was very pretty. Luckily, it also wasn't freezing cold. It was one of the warmest days in a while up here. So so I got up there and everything. So I called that then Vanessa. I'm like, you guys aren't gonna believe this, but you guys aren't rid of me just yet. I kind of my car died. I was like, oh geez, all right. So they get on the way there, and I'm like, I don't think I have my AAA. My mom sent me the email. Like, call my mom. She sends me over the stuff and everything. So I call AAA, and then they have it's like a Domino's pizza thingy there. It's like estimated arrival 57 minutes. I'm like, you haven't even assigned a driver or anything yet. You haven't assigned a truck. I'm just like, this is like saying your pizza will be ready in 26 minutes. It's like Joe hasn't even started making the pizza yet. It's like, no, but they called and everything. They called, and then there was a nice gentleman. Oh God, what is it? Thomas. Thomas did an excellent job. He got up there and everything. He met us. Fortunately, there was room for a flatbed to actually turn around and everything, and it wasn't like let's back up slightly into the creek or something. That would not have gone well. Needless to say, oh, the other gentleman, Rick, he had helped me just give the car a little nudge, and so there was that like a little bit incline. I just kind of steered it back so it was off the road. So again, of the places to break down, it was the best worst place. Excuse me. Yes, the best worst place. I was trying to run through that analogy in my head, but welcome, my friends. Welcome, my friends. Again, we have Mark, we have Rick, Lug, Kale. Ooh, I hope you're all right, Kale. It's I see. I was fortunate. It wasn't an actual auto accident. Long story short is after I went underneath my car, I'm like, oh, I just got an oil change. I think somebody forgot to tighten something because like oil when it's cold kind of has higher viscosity and stuff. Excuse me. But as things increase in temperature, the viscosity may change. And so that's one of the reasons why we're kind of doing this today is rather than me just rant and be like, oh my God, oh, I need to blame people. It's like, oh, accidents happen, statistics happen. Uh, but long story short is we tow it back. We get to the place where I got the oil change and everything. They were still there. They bring it into a bay, yada, yada. And then I get the call later this morning. I figure I'm like, best case scenario. Yeah, like 6 quarts of fresh oil, give the drain plug another half turn or something. We should be good to go back on the road. I was incorrect. It ended up being the worst case scenario, which sounds like the engine seized. So, and for those that have been here for my early few minutes of rants, um, the the ironic part is it was a brand new engine. Like when I say a brand new engine, not like all right, something got wrong and you toss a new one in. I got the extended warranty. It flashed the codes that you need a new engine. They got me a brand new crate engine. They put it in less than probably about 5,000 miles on a brand new engine, and it just seized. So the guy called me this morning. And he's like, "I owe you a no motor." Okay, so I go over to grab the stuff, and they had already had it. They pushed it onto a flatbed, and they got it over to an automotive shop there where they're going to do the work and everything. And then as I was going to go get in the stuff, I'm like, "Listen, I don't want to necessarily be that guy. The one thing I need to insist is when I'm getting a new engine, I want a new engine." Well, sorry about that, but when I say new engine, I'm not saying like, all right, this came out of a vehicle. It was rear engine and stuff. The thing is junk. The motor's still good. It's got like 80K or something on it. It's that was a brand new motor installed by the dealership with like 5,000 miles on it. They had already had to wait like a month and a half plus to actually get and everything. Uh, it was a pain in the butt. So ultimately, I'm like, I think I got the paperwork in the car. I didn't have the paperwork in the car. Apparently, I probably left it at home because I'm like, all right. Usually, just oil change. I just toss in the glove box. I'm like, this is important paperwork. Apparently, I didn't put it in the glove box. It's probably at home in like the safe or something like that. And it's like, all right, well, what the call up the dealership. I'm like, blah, blah, blah. I'm like, all right, can you send me that paperwork? They were closing up because it's East Coast on a Friday. So, like, oh, well, we should be able to get to you probably by Monday. So I let them know, blah, bada boom, bada bing. I'll email them all the paperwork saying, all right, you guys owe me a new engine. My thing is, listen, we all make mistakes. How we handle them is what defines this. Now, some folks, and don't get me wrong, I understand sometimes, occasionally, not all, and probably even not most. Occasionally, a bad thing happens on the internet. It's like, I got to put you on blast, blah blah blah. Do all this screaming. It's like, no, I've gone to this place a bunch of times. They've been honest with me and everything, and you make this right because it's you accidents happen. It's like, well, if you're doing math and science stuff, it's like, well, there's kind of this thing called statistics. Given enough iterations, different things happen. People make mistakes. Just make it right. All right, so we're gonna go over. Yes, no organ donor cars. That sounds terrible, but yeah, no, it's all right. Hey, we'll get it. And you know what? I'm gonna take it as I know a lot of folks aren't very religious, but I'm gonna take it as a sign from the Almighty that maybe I should stick around here a little bit longer. Hopefully, I can go home for Christmas. It gives me time to actually finish the paper that I had yet to finish and everything, and then I was able to start working on it again. But today, what could go wrong? All right, let's diagram out what went wrong. I am so glad my hot chocolate did not scald my throat. I took a very deep gulp. That is something that often goes wrong for those of us that enjoy a hot beverage. All right. You want a little dose of caffeine, perhaps some coffee, some tea. Oh my God, I sound like I'm from Jersey. Some coffee. Oh God, that was an even worse Jersey accent. Maybe a hot chocolate, but you take a deep swig. And especially, I know it's a terrible thing. Anastasia would probably lose her mind right now if she was watching and be like, memes, the microplastics, the microplastics. I like Keurigs. I like Keurigs. I still need to find a little reusable thing that I could probably just order one online. I'm just scatterbrained. But occasionally, my Keurig at home, I let it sit for literally 90 seconds. It's drinkable temperature. It's still hot, but tolerable. At the monastery, a son of a gun comes out of probably like 120 degree. It's very, very hot. Oh my God, I should start measuring my temperature, my coffee in Kelvin, shouldn't I? See those little science things you can do. Eh, But occasionally, if you miscalculate, now if you just drink a tiny sip, it's not that bad because it's kind of like intensity, area, duration, or was intensity, exposure, and then the amount of time or the number of iterations that bad things could happen. So it's kind of like when you get a really hot pizza too, and you want that pizza and it looks so good. And you take that first bite and you're like, I just burned all the taste of the entire roof of my mouth off. Guilty. Okay, so what happened? All right. I'm gonna detail this case. I wanted to go from the monastery, little terrible. Wow. I can still not draw houses and stuff like that. All right. This is gonna be M monastery. I wanted to go wee all the way home to M-A. Yes, there, we'll do this. M-O. Okay, that sounds like Montana. Okay, it's monastery. Monastery to M-A. This was the goal. Okay. Not to scale. Okay. I feel like that's an important thing. I don't know. Occasionally people on the internet might be a wee bit pedantic. I resemble that remark. Okay. So the goal is to go from here to there. So in order to try to get that done, I'm like, all right, here's what we're gonna do. We're gonna get new oil. So we're gonna get a little fresh bucket. Yes. Full of oil here. And then we're gonna get a battery, plus, minus. All right. And then we're gonna put that all in our, oh my God. Do I even dare to try to draw a motor vehicle? All right. There. Okay, here's the memes mobile. Memes mobile. Okay, we've got it there. We're loaded up with our oil. We have our plus and minus. Wanted to get at least a good 8, 9 hours of driving in and get a room maybe at like 9, 10 o'clock at night, crash for the day, and go visit some friends later. All right. So we got to Mountainous Pass. Okay. So we got all the way to here. We did not get too far. We did not get too far. And and unfortunately, yes, that unfortunate face was the end of the memes mobile. No, excuse me, that's not correct. Just just the engine. Just the brand new engine the dealership had put in like literally 2 months ago. No, that just beat all. Okay. Why the heck did that happen? Because my thing is, well, I didn't. It's my fault because I did not check under the vehicle to see if it was leaking oil. Well, that's like there was no oil under your vehicle at all. And I'm like, okay, so it sounds like it was tightened the drain plug at the bottom because like if you ever done your own oil or something, will be like they'll have like the oil pan, and they'll have like a little plug here, and you want to tighten it, but you don't want to tighten it too much because if you tighten that swishy oil, woo, and then that oil goes up, and that cuts the cylinders, and they can slide and they can slide, but once they don't get that oil, and you've still got that same heat, and it's a combustion engine, and how the heck does the combustion engine work? I don't know. It's what is it? You got your cylinder, you got the thingy that comes down, your piston and everything that goes up through there, that goes up. All right. So basically, you get your injectors. They spray in some fuel mixture. You got your spark plug wherever it goes. Oh God, spark pluggy. Okay, I know. And it ignites, and then you get this kablooey and everything. But the thing is, if it's going to be doing that on a regular and frequent basis, maybe thousands of times a minute or something like that, I think is the standard RPMs, revolution per minute, something like that. You also want your oil coming. Excuse me. You want your oil coming in too. So you don't have that oil coming in. You can have that lubrication and get hot as long as you have that viscosity there, the ability for it to just continue fire. Then you'll be fine. However, this oil is kind of gets hot as its viscosity is changing, and then that starts leaking out, and you're putting your engine under a load because you're kind of driving up a mountain pass a little bit there, and you lose oil, and you lose more oil, and you lose more oil. Eventually, yeah, it doesn't seem to be working well. It don't seem to be shifting. And then the first response is, oh, maybe it's clogged injector or something. You give it a little gas, and it's like, oh, this is not good. I'm like, go over, turn it off. It's racing, and turn it back up. No, no, get up. Oh, look at all that oil. It's just out there and everything. So it's like, all right, well, what do we do? So it's first response is, oh, we don't got no towers high enough. We don't got no signal right now. What are we gonna do? Well, my first thought is I gotta hitchhike back. So I'm like, all right. There, I'm like, I'll just well, I have notebooks with me and everything. I'll just pull a page up. My notebooks are full. I need to get a new notebook. So it, and so I tear off like the front cover of one of the notebooks. I'm just like, all right, leave a note because I actually brought pens with me for some reason. I'm like, all right, leaking oil. We'll be back with triple A. Because you're supposed to leave a note because, like, I don't know, what's going on? Is this person just missing or something like that? No, no, no. It's leaking oil. It's here for a reason. Blah blah blah. We'll be back. Okay, but yeah, it was the first little piggy. And the Trojan horse. Hey, it's as far as I know, I think it was fine. The only thing that I cannot confirm, when I originally brought my vehicle in to have the engine changed the first time, I believe there was a little bit of water infiltration in one of my headlights. It was slowly starting to fog up a little bit. By the time I got it back, like a month or so later, I had fog in both my headlights. So I'm like, well, I'm sure nobody taking apart and putting together an engine would ever put any additional pressure on the headlights and cause little hairline fractures, and then water gets in, yada yada. I don't know for sure. And by the time I kind of remembered, I'm like, well, I'm heading back out to Utah in like 2 days. So I'm like, whatever. Hey, at least give me a chance to get some new headlights before I travel back across country. Maybe that's why it happened. It's like you're gonna be driving at night. You can barely see. So maybe you should get some new lenses and stuff like that, because they have to sell you like the whole thing because that's modern headlights now. Uh, New lights are actually very bright and do help a good a bit. But so that's basically my just standard antics with still being here right now. So I figure I'm like, well, I'm back though. Might as well start do the little workout thing, do this because well, it's a weekday and what's my excuse? I almost did it yesterday, but I'm like, yeah, I'll probably leave in the morning. I want to get a bunch of sleep and stuff. So yeah, apparently I'm sticking around here for a little while. So I guess you all are stuck with me too. So anybody that temporarily watches in the future, um, what is I don't know. Any other comments or anything? That's basically just the end of my little jaunt and rant and picture that to anybody looking, it's like, okay, so it looks like a preschooler did that, but a preschooler would probably do it better than that. Um, they could probably even spell better than me and have probably better penmanship. Um, but yeah, no, other than that, uh so we did some more science stuff. Good. Shall we conjecture a bit more ahead? Okay. So the original assessment was all right, it's holiday coming up. It's like, all right, I could probably get you back probably mid-December. And that's like that was before. And no, see, yeah, I need a new engine because it literally was a brand new engine. If at 8,000 miles, give me an equivalent. I understand that. Had it literally not been installed 2 months ago, like a brand new engine, and then it's like, oh, yeah, well, I was fine. And the terrible thing is, you sit there, you're like, what if I had done the lazy thing and still drove and had not changed my oil? I'm like, maybe I could have just thrown a quart in. It's like, it's not good for the vehicle. You want to keep it fresh and keep it lubricated, but yeah, yeah. Hey, coulda, shoulda, woulda. But yeah, now I'm here with you all, and get a chance to continue focusing on some science for at least several more weeks. Maybe I'll be able to go home for Christmas. Uh, I don't. I don't know. Should I see if they could get me a rental? Uh, I think I'm here right now. If it takes longer than Christmas, I might need a. You guys are gonna get me a plane ticket or something like that. It's like, listen, I don't want to be the dude that's is the 1-star Google review that it's like, yes, going home for the holidays. A- I got an oil change, a new battery, and a seized engine. It's not a good review and stuff. And it's like, hey, it was straight up. It's like I owe you a motor. I do feel a little bad and having it to be like, yeah, you owe me a new motor, like new motor, because they literally just put in a new motor. So I told the story to the guy at the shop as they're like winding down for Friday from where they had originally replaced it at the dealership. I told him the story. He's like, that's insane. I probably just wanted to get me off the phone and everything. It took down the details, yada yada. But it's just like the level of irony in it is just, oh, it's yeah. What do you do? Just freak out? Oh no, oh, I'm off schedule. Oh no, hey, life throws you lemons. Just make some lemonade. Uh yeah, yeah. You got to break it in. It's yeah, you got to be careful. Oh, San Diego. I don't think I've ever been there. I don't think I've ever actually been to almost went to California. We were in Southern Oregon, but no, we didn't cross over to California, I don't think. Going, I think, along the Winnemucca Road. Why? Because it was in that song or something. So well, it seems like a good time. I wouldn't mind going to California. It's part of a Rob Zombie song. It's like, go to California. It came out a long time ago. But I hear the weather is great, and no, those are Professor Keating's romping grounds over there. So, uh, what else could we go through aside from just a little bit of rambling and stuff? Um, let's do this. I'm still, I'm still trying to figure out what to do, but you know what? I'm gonna take a sip of some hot chocolate and wipe down the board. I started to do that. I realized, should I actually be drinking and trying to do this at the same time? Is this like trying to like pat your head and run through your stomach? Like if you don't have those neurons connected or something, like it seems very weird, and you start like arbitrarily rubbing your head and patting your stomach or something. I don't know. The I think I was already kind of good at that, but maybe it was just because for some reason I tend to be right-handed, but I use a knife in my left hand and a fork in my right, and that's supposed to be backwards. I don't know. I don't know. That never seemed to bother me. Okay, it's a little bit more that way, but it's I don't know. Maybe I'm just a polarization of stuff and things. But oh, the the it's it again. My general thoughts is a bit for publishing, just just a little bit. That's all I think. Just just get your name out there. That's it's what I think I was originally going to comment on Professor Carroll's his he does a call for AMAs. He was doing the last one of the year this year. Shout out to Professor Carroll from the Mindscape podcast. And originally I was going to say, inspired by your presentation. Oh my God, we keep forgetting her name. Okay. I'm finding it right now because this is inexcusable. It's Dr. Sean Carroll. Carosini? I think it's Italian. Uh, Carrie Cesarati. Carrie Cesarati. Dr. Carrie Cesarati. I hope. Um, hold on. Let me bring up the transcript. I want to see. Hold on. I'll share this. Hold on. Well, we'll bring up the Mindscape. I mean, people literally rip entire Mindscape podcasts. Okay, maybe not always. There's some folks that take like the entire presentation and don't even attribute it. It's like, oh God, it's meh.
The
Citation
experimenters have
is
not
important.
slowed down. They've not gotten worse at their job. But the new data is still in. Capstone of this, of course, was the discovery back in the 1960s. 19 is not the final answer. Of course, it doesn't in dark matter. Why are there so many questions that are looming? That there this wonderful ability for it's hard. Time scales proceeds. Go in there is at least as
Oh my!
difficult. You know how and
Why
in
are
his
you
day and
so
age, you need a lot
thorough,
of
Professor
political will.
Carroll?
It's a more than one country kind of internet
Carrie
was super
Cicerati.
psyched. One more Nobel Prize to be given out. The question is where to go next. Strongly think that it's not true. The folks at CERN, Collider or build an ultra high, is a particle theorist.
Looking
she
for
works
muon
on
collider
building models of new kinds of particle physics. Literally, the experiments you can sitting back in the armchair and the way that she is most fond of space time, as some people are wont to do. She wants to make predictions and then go test them in a very, very detailed tested. But she's especially interested in, we're not sure what we're going to do next. Today's guest, Kari Cicerati, is a particle theorist. So she works on building models of new.
Kari Cicerati. Okay, I feel so much better. Forgot her name like so many times. I need to get proper attribution. So basically, Professor Carroll was doing his call for questions at the AMA earlier, and originally I was going to be like, inspired by your conversation with Dr. Kari Cicerati and everything, I'm starting to write my own paper. Then I realized I sound very conceited. I'm just like, all right, just put yourself in a general blah, blah, blah. It's like, oh, I'm like, oh, look at my idea and everything. And I realize it's like, I've done sales. I've done corporate sales for like a decade. And everyone loves to buy. Nobody likes to be sold. So eventually, I was writing out this whole post and I actually accidentally hit enter. I had to delete the post from Patreon. And then I'm like, okay, let me just do this. In your conversation, blah blah blah. You mentioned what was it? The relationship between the Planck mass and the Higgs mass squared, and its relationship. Is there any literature on the coincidence of basically the Higgs mass or the Planck mass squared being of the magnitude 105 times 10 to the negative 34 and being coincidentally of the magnitude in first several digits of H bar? Just keep it short, because at least for me, like a general search and on the archive and stuff, I'm like, I don't see this combination of like letters and numbers if one was to assume that there was some there. And again, it might just be a complete coincidence or anything. I mean, it's not like the mass of the Higgs takes what it is because that is required for the elementary unit of action to do its thing. I mean, that would be pretty cool. I'm very biased on that just because I'm also writing paper and everything. So I've already kind of presented these out here. It's like, for me, I'm like, oh, the internet is kind of time stamped and dated. So if you really want to go, okay, the thing that got me back, God, I think it was like 2013. There was a period, maybe it's changed. I don't really use Facebook much anymore, but I remember at one point it went from post to publish. Literally, I remember it was like, I think I was around, I don't know, probably about a decade or so ago, for at least a short period of time, for me at least, the thing on Facebook said publish. I'm like, wait a second. They were publishing things. I feel like that was an attempt to get people to think about what they were posting rather than I'm posting this, No, you're publishing. This rule two of the internet, my friends, is the internet is forever. It's now in some way, shape, or form, maybe not. Yeah, it's forever. If you put something out there, assume there's going to be a copy of it somewhere, for better or worse. But my thing is, what am I going to do? It's like, okay, so before I go out there and criticize the establishment, all those ivory towers and everything, it's like, oh, those are the people like Sean Carroll. He's like, yeah, no, occasionally, if you're in academia, I got friends that are in academia and stuff. It's like, no, it's you're in a pretty good position and everything, and you don't only really have to worry about like your research and everything. It's like you might not be conscious of all the different things going on around here, or if you spend a little bit of time on social media, one's perception may be a little distorted from reality. Because rule one of the internet: don't believe everything on the internet. It's not like the same people that were they were complaining about don't believe everything you see on TV, and now saying, man, Can you believe what I saw on the internet? Rage bait. I digress. No, but so I'm gonna go through it. I'll put it in the formats. I'll submit it to. Hey, I mean, I know Wolfram has the complex systems journal and stuff. I'm like, all right, I'm not sure how much of a complex system is, but the general thought system is kind of based upon computational reducibility. What the heck am I talking about here? Computational reducibility. All right, let's go back over to our friend over here. Let's do. Thank you. I'm going to go with Dr. Kari Cesarati. All right. Wolfram, go. All right. So when we say computational reducibility, you do something like this. You could do e squared. Let me big it a little bit. E squared. All right. And we're going to divide that by 4 pi h bar c electric constant. All right. We put that in. What do we get? Oh, that's terrible. Oh, wait, hold on. Elementary charge. There we go. That should fix it. There we go. It was doing Euler's number. I said it. Euler, Euler, Euler. Elementary charge squared. All over 4 pi times h bar times c times e naught. What does it give us? Oh, look, that appears to be alpha, aka the fine structure constant, to our approximate magnitudes of measure. Some of us may disagree with that last digit, but that's okay. There may be reasons for that, or we could just be wrong. Again, I am very biased on that. Okay. This whole dang thing gives you this. All right. So what if we did something simpler? E divided by blank charge. Square the whole thing. Okay. I need to write it out. Elementary charge. I was hoping he would do the shortcut for me. Okay. So we got those two things we square. Oh, look. We get our friend out again. So it's basically just taking inspiration from alpha because what was that whole dang thing down there? The whole 4 pi, whatever that is. Nowadays, it's very easy because you get tools like Wolfram Alpha, Mathematica, whatever you want to use. And you get this thing here. It's 3.5, 10 to the negative 36, and like second squared, amperes squared. What is that now? My friends, the interesting thing is, if you do the little mathematical calculation of time times current, you get a friend. You get our good old friend if we square root this thing, because, well, our top, if we're getting a dimensionless number and the top is squared and it's a charge expression, the bottom's going to cancel out to a charge expression squared. Oh, look. This is an old friend. What is that? Oh, look. It's the Planck electric charge. Go figure. I mean, that is literally computationally reducible into something more simple. So it's like, all right, I'm just taking that concept. And again, people know about that. I watched a presentation where somebody was talking about that, where it's like, but is that widely known? Well, I mean, is there a reason to know it? I mean, you just got the number. You're just using the number for your calculations. Who cares where it comes from? I mean, unless you're trying to get some intuition, this, that, or the other thing. So it's not like we're just telling people, hey, don't ask no questions. Just sit there, be a good little doobie, do your calculations, and incrementally build upon this, that, or the other thing. Now, you can do that. I'm not to be fair. Usually, when I actually like stop rambling on the internet and actually sit down, put on some anime music to get in the zone, and actually go through and do calculation. To be fair, that is when I usually actually like generate useful things, or what I would claim, or perhaps just hope, are useful. But well, see, the thing is, Rick, that's why you start off with pieces, small little pieces, because also like this little thing that I'm talking about here. So what the heck am I talking about here? Basically, with Carrie Cesarati, you just do was it eggs mass over the Planck mass, and that's about 17 orders of magnitude. Okay, it's saying it's rounding, so it's about 17 orders of magnitude. You square it, and you get this here, and you're like, okay. And again, if you're not sitting around doing lots of calculations, 1.05 times 10 to the negative 34, that shouldn't mean anything to you. It just sounds like a really tiny number. Now, it is a really tiny number. Apparently, some folks thought it was going to be zero, but good friend Professor Max Planck uh, apparently did a calculation, and initially he got about, actually, no, it was about 6.25 times, because he had the 2 pi factor in there. Because you see, this is basically the magnitude of h bar, the elementary unit of action. Pops up in quantum mechanics and stuff all the time. It's why it's the unit of action. Okay, what is action? It's energy per time. If you do the whole little, let's go here, blah, blah, blah. So let's just say we do the Planck mass, c squared, get our Planck energy. Okay, we get our energy. All right, now we multiply it by the Planck time. Planck time, boom. What's going to happen is, remember, we got a c squared there. That's length over time. So we're multiplying by time. That's going to cancel out one there. So now you're just going to have multiplication. It just thinks I want lists. Oh, was it wrong? Okay. So basically, you get mass, and then energy would be length. Was it length squared, and then it'd be time to the negative 2. Since we're multiplying by time unit, we're getting time to the negative 1. And so the interpretation is angular momentum or unit of action. Okay. So all we're doing right here is we just go through. We're like, oh, that's coincidence. Again, it's a coincidence. Got the first 3 digits of h bar, and again, it's in dimensions. It's not in the right dimensions. And then you look at that, and you're like, oh, it's about h bar. So I'm like, well, what if I move this dude over here? What if we made it a larger magnitude? Just because I think it's prettier when you multiply it by h bar. So you do this, you're gonna get about the inverse. All right, don't worry about the number there. Just throw in your h bar, bada boom, bada bing. I'm like, so again, it's estimating here because we only have a couple of digits of accuracy. It's like about 1 joule second. Now, here's a question. What is one? Seriously, like one what? Can we add apples to oranges? What if we decompose them into their elementary constituents? Could we get a feel for what's going on? But I just look at that. I'm like, okay, wait, hold on. I'm going back here. I'm like, let's go back to the other one. That's only 3 significant digits. It's like, yeah, you don't have that much accuracy. And then you're like, wait a second, how about the mass of the Higgs? Okay. This was the 2023 measurement. There was a more updated one. So, according to the CMS experiment, it's about 125.35 GeV. All right. Uncertainty of about 0.15. Those last 2 digits could go up, could go down, about 0.5 within that. Uh, so, okay. The Atlas experiment was about 125.11 GeV with 1 error. But the interesting thing is when you see something like that, you're like, all right, we think we only have, okay. You look at this, you look at we'll go to the other measurements. Ba, ba, ba. Uh, Okay. No, those were early ones. 125. Okay. So right now, CMS 125.35, 125.11, Atlas 2023. And there's been things above it and below it. And I think most of them are kind of above it, but generally around that range. Okay. So you do that little thingy. Okay, we go back. And then it's like, wait a second. So we have confidence in about 3 significant digits there. Those 3 significant digits seem to match with the first 3 significant digits of something that a lot of people find very useful. What if we were to conjecture there might be a there? What do I mean by this? Well, okay, the Higgs mass, we only have for measurement. We have some calculations to kind of get it down within a range that basically makes physics work, apparently, to our modern understanding. Um, but we only have that measured to about 3 significant digits. The Planck mass we have calculated to 7, the last 2 I've ever. So, but we know 5 solidly. Okay. Now, if that's coming out with about 1 joule-second, can we just set it equal to 1 joule-second? Isn't that how we like literally quantifying h bar? So I'm like, all right, I ain't no Einstein, but Wolfram is coming out with an algebra tutor, an AI algebra tutor. So maybe that could learn me some algebra. What do I mean? What if we did this little thing? We did our little inversion trick. We get it about to the magnitude, okay? But instead of plugging in the Higgs mass, because we only know 3 significant digits to that, what if we did something silly like this? We throw our h bar in there. So we'll get over there. Okay, so we throw our h bar in there. It gives us about 1 joule-second. Okay. What if we set it equal to 1 joule-second? We went into the Higgs, and rather than plugging in the Higgs, we solve for x kilograms because we have a mass term over there and we need to cancel it out. So we solve for x kilograms. Oh, we get this. Interestingly enough, since it's a squared term, we have positive and negative answer. We'll leave that be for now. We'll take our positive. I mean, you could express an absolute magnitude or something if you wanted, but as simplicity may be trying to tell us something. All right. So we're solving for kilograms. Let's do the energy equivalent so we can compare what we had there to what we had there. Okay. What do we get? 125.37 GeV. Now that doesn't seem exactly like what we had, but it sounds good. What do we have? 125.37 GeV. Let's go to Higgs mass. 125.35 GeV. And again, that was CMS 2022. Wait a sec. 125.35 GeV from CMS measurements. With 125.37 GeV, according to theoretical calculation. Now, listen. I'm not saying that's the mass of the Higgs boson. I mean, I have no idea. I mean, there's been some measurements right around in the ballpark, and maybe 1 or 2 that's only 100, like right about spot on around there and everything. So you can't call it a prediction. If anything, it would be a explanation for why we may have observed it at those masses. Ultimately, if we want more certainty, we're going to need to make a lot more Higgs bosons. And the best way to do that, theoretically, would be to build a muon collider. What's a muon? It's like the older cousin of the electron. It's supposed to be the exact same, except about 206 times more massive. Why? Because, well, as far as we understand it, some elementary particles. If you smash elementary particles together, well, whatever comes out, we know like it was those elementary particles. Rather than you take some protons and you smash them together, or protons, antiprotons, or whatever. So you smash them together, it's like maybe you're getting out constituents. Just say you smash a couple protons together, it's like, all right, we got some quarks, we got some gluons, all this stuff according to our calculations and our models to the best that we know it or is generally accepted within different communities. All right. It can be hard to kind of be like, all right, was this a Higgs boson? Was that a Higgs boson? It sounds a little bit more difficult. But if you have a muon, which is more massive, and you could smash those together, theoretically, you could make a heck of a lot of Higgs bosons and probably get some really good precision measurements. Now, the problem with doing that is one, muons decay after like, I don't know, a couple of microseconds, maybe, I think it's microseconds, it's around the magnitude of about 10 to the minus 7 seconds, I think. Something like muons decay really quickly, but not so quick enough that we might have some really smart experimentalists. Apparently, you got to make them, and then when you make them, you got to try to focus them into a beam because they're doing their muon thing and everything together. And even Dr. Carrie Cesarati had said, yeah, if you're just making a bunch of muons, you're getting this like big cloud of muons. You get a big cloud of muons, and it's like, all right, now you got to kind of make them try to go single file, get them into a beam, accelerate them. Well, apparently, number one, they've been able to actually make a whole bunch of muons, put them into a beam, and I think I got to about it was either 0.4 or 0.8% the speed of light. And yeah, nowhere near as fast as we want them to be going. But I remember that interview. She laid out the things, and that was about like three months ago, something like that, 2 or 3 months ago. And you go through it, and you're like, okay, well, checkpoint. They're able to make a bunch of muons. All right, they're getting into a beam. Now it's starting to accelerate them. I'm like, my friends, in another couple of years, we might actually have a muon collider. And personally, I'm very biased because I'd like to see if we get some more significant digits because it would be pretty cool. Because I mean, most likely it's wrong. 'Cause, most things are usually wrong, but every once in a while, somebody notices something very interesting, and I think those interesting things are worth exploring. And if it happened to come up that we had 125, 137, and you're able to have high confidence in that, and the measurements seem to bear out, well, my friends, perhaps that's a way to help explain why the Higgs boson has the mass that it does. Because the claim would be the mass of the Higgs boson is the mass of the Higgs boson because it is required in order for the elementary unit of action to take place. I mean, isn't that what a lot of folks say anyway? Where it's maybe not in those exact words, but it's like, all right, we start off in a very hot, dense state, and then we need to cool down. And once we cool down to a thing, like the Higgs field kind of like freezes into place and then does its Higgsy things and everything. I'm like, what if in order to get Higgsy with it, excuse me, we got to get Higgsy with it to be able to take action. I have no idea if that's a correct statement or not, but it was fun saying it. But it's just a fun little calculation. And if there was something to it, because all I'm doing is like that is like he put that little kind of brainworm in me. It's like, what is this one? What is this XY in which we live and everything? And it's like, I have no idea. But I'm trying to get ideas, and that's why I talk with a lot of different people. Talk to a lot of folks about a lot of different things. And listen, the best and worst part about the internet is you never know who you're talking to, and for better or worse. And then sometimes you know who you're talking to, and occasionally you get ideas, and some of them it's like, all right, that person might be completely off their rocker. Occasionally that does happen. Statistics are a thing. But yeah, I mean, you're looking at one right now. But it's one of those things where if you get a large enough sample size and you just kind of like put markers down, it's like, all right, where should I spend time? What is worth spending time, maybe 5 minutes, maybe an hour with somebody? Is it worth doing it in a broadcast? Is it worth going to see somebody because they might have something very important to say? Now, these are all different factors. We try to weigh them according, and then people are also busy. If you don't have time to think about stuff, it's like, yeah, it's like I'm gonna do this stuff. I'm gonna work on this. It's like you're going through your work and you're getting burnt out and everything, and then it's like you're tired and oh my god, heaven forbid if you have a family or something, because you got to do all the family stuff, and then at the end of the day, it's like, what am I gonna do? It's listen, I just want to wrap up this game of Jeopardy, or I can drink some chamomile and just hit the hay. Why? Life can be really tiring. People can also be very taxing at times. Now, it's not always a bad thing, but you kind of gotta try to find a little balance. But with that, we've gone through a little bit of some stuff and things. I got a little rant about my busted vehicle, but got me some time here at the monastery. So yeah, basically to wrap up, my plan is just finish up this little paper and stuff, and then I'll submit it to the powers that be. Maybe I'll use a monster email address or something, and just very simple. Just this is what it is. I'm not going to infer other things. Just this is just base interpretation. Give plenty of citations to the different folks and everything. And hey, we'll see what happens. And if nobody bites them, we'll just go to the Wolfram Summer School. It's like if people are talking and actually, shout out to Carlos Zapata from Team Wolfram. He's actually got his own little small institute. They did their first summer school, SEMF. I'm part of them and everything now, and we get to share things every couple weeks. And it's good to have some folks that have worked in the industry, and they all also publish different papers and stuff, and just share some ideas and see if things are worth exploring. Because, well, that's the goal of science. Is to, well, I would say level up, but I'm going to still say level up. Why? Because I can. But hey, I believe the game never played. Can you really hate on it? Of course you can, but I think playing the game at least a little bit may be able to give some self-reflection. I ain't saying that the game ain't always isn't always not rigged, but hey, sometimes the game must be played. But hey, exactly, look, those are the things. You just got to count our blessings every day. My thing is, I didn't break down in a place with not a lot of folks around, surrounded by wolves. That could have very easily happened. But hey, God bless. Got back for dinner. So that's all we got. You all have a great weekend. Take care of yourselves, and we should be back on Monday. So hey, zombie, good to see you, my man. Other than that, peace out, everybody. We'll catch y'all next.